What's up, everyone? Welcome back. Patrick here. Moving on to the next example in the exponential functions unit test. So here we have to take the function y equals 8 to the power of x and rewrite it in 3 different ways, and all 3 ways have to have different bases. So this is a pretty cool one. I'll try to give 3 ways. Maybe if there's any more that come to mind along the way, I'll give those as well. So different ways we can go about this. Let's think about this. We got 8 to the power of x. What we want to do is we want to rewrite this 8 in different ways. Well, one way that comes to mind is, okay, this 8, it's like over 1, right? Well, what we could do is, if you remember the rule, let me maybe write in a different color on the side. If we have any fraction to an exponent, well, that's the same as the reciprocal of that fraction to the negative exponent, right? Usually we go this way, but since we have a positive exponent, I wanted to write this expression first because we're actually going to write it in this way over here, right? So if you have a fraction to an exponent, that's the same as the reciprocal of that fraction to the negative exponent. Okay, to changing the sign of the exponent. So what we could do, applying that here, we can rewrite this 8 over 1 to the power of x as 1 over 8 to the power of negative x. Right, so that is one way we can, sorry, I wanted to rewrite it with a y over here, make it still look pretty. So y equals 1 over 8 to the power of negative x, like that. Okay, so this and this, they're the exact same function. If you were to take both of these and plot them in Desmos, you would see that they would overlap. Right, so that's one way to go about it. What's another way to go about it? Well, we could take the 8, that's going to be 8 to the power of x, and we could rewrite 8 as 2 to the power of 3. Right? 2 to the power of 3 is equal to 8. And then we have this x. Then over here, using exponent rules, you can multiply those exponents, because if you remember, if I have something like a to the power of x to the power of y, I just multiply those exponents. So applying that rule here, right, you can multiply these. Y equals 2 to the power of 3x, like that. So that is another way that you can go about it, right? So again, check these on Desmos, plot this, and then right under it, plot this, plot the original function that we were given. Again, you'd see that all of them would overlap. All of these are the same. And then on this, actually, I could apply the same rule here, that reciprocal of a fraction rule, because this, it's like 2 over 1, right, to the power of 3x. So I could rewrite that as 1 over 2 to the power of negative 3x. Just change the sign of the exponent and then take the reciprocal of that fraction, which is 1 over 2. Okay, so that's another way to go about it. And notice that all of these, as required, they all have different bases, right? So the first one had a base of 8. This one has a base of 1 over 8. This one has a base of 2. This one has a base of 1 over 2. Okay, so these 3, they are different ways to rewrite the function y equals 8 to the power of x in 3 different ways. All of them have different bases. Another one that comes to mind, this one's going to be a little bit more tricky, but we can actually take this 8 and we could rewrite it with a base of 4. We could actually rewrite it with an infinite amount of bases, but I'm not going to say an easy one, but an easier one to rewrite it as a base of would be 4, because 4 and 8, you could rewrite both of those as a base of 2. So what you could also do, you know what, let me just erase all these here. I'm going to probably need some room to show this. So what we want to try to do is we want to try to take 8 and rewrite it as 4 to the power of something. Let's put an m here. Let's not put an x so you're not getting confused with this x that's given. So let's just use another variable here for now. We'll call it n. Question is, can I take 8 and rewrite it as 4 to the power of some kind of value? And you can, because the 8 we could rewrite as 2 to the power of 3, and the 4 we could rewrite as 2 to the power of 2, right? Same basis, so you can multiply these. And notice you have 2 to the power of 3 equaling 2 to the power of 2m. Well, same basis, you could just drop the basis. Divide both sides by 2, so m would be 3 over 2. So going back to here, basically 8 is equal to 4 to the power of 3 over 2. If you took 4 to the power of 3 over 2 in your calculator, or 4 to the power of 1.5, you would get a value of 8. So going back to the function, we got 8 to the power of x. Well, we know 8, as we just showed here, is equal to 4 to the power of 3 over 2, or 1.5, which would be 4 to the power of 3 over 2x, like that. So that's another way to rewrite it, right? That's another function that has a base of 4. Y equals 4 to the power of 3 over 2x. Again, if you put that in Desmos, you'll see it will overlap with all the other graphs that we've, all the other equations that we talked about. And then you could have fun with this. I mean, you could go the other way, so you could actually rewrite 8 with a base of 16, because 16 can also be rewritten as a base of 2. So you could go, okay, 16 to the power of what would give me 8? Well, 2 to the power of 3 equals 2 to the power of 16 is 2 to the power of 4. Multiply those. So you'd have 3 equaling 4m. So in this case, m would be 3 over 4, or 0.75. And if you put 16 to the power of 3 over 4, 16 to the power of 0.75, you would get 8. So if I got 8 to the power of x, well, I know 8 is equal to 16 to the power of 3 over 4 to the power of x. So another potential is that right there. If you graph that, it would be the exact same function. All right, so kind of went off there a little bit. We only had to give 3 different ways, but just so you could understand how these different exponential rules can be applied, there's an infinite amount of ways that we could take this function 8 to the power of x and rewrite it with different basis. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.